You ask AI to build your entire app. Seconds later, you've got folders, dependencies, and hundreds of lines of code that look impressively confident. But how do you know any of it actually works or even what it does? When you're new to software development, a complete-looking response can easily feel like a completed app. But appearance isn't validation. Generated code still has to compile. It needs tests. You need to pay attention to its warnings and errors. And before you use any of it, you need to review it closely enough to understand exactly what you're accepting. So the better question isn't whether AI can produce a lot of code. It's whether you can inspect what it produced, test it, and confidently keep building from there. Before you request any code, give the assistant a destination. Begin with the overall goal. What are you trying to build, and what should it accomplish? From there, turn that goal into concrete requirements. Describe the behavior you expect, the constraints that matter, and what a successful result should look like. This separates your destination from the first implementation step. You're not asking for everything all at once. You're making the intended outcome clear, so the next small request has a direction. With a vague destination, the assistant has to fill in important blanks for you. Concrete requirements bring those choices into view and give you something you can review before the code starts piling up. Examples make that destination much easier to interpret. Show the assistant a sample input and the output you expect. If you already have a small implementation whose style or behavior matters, share the relevant example. Keep it focused on the result you want the assistant to understand. If the feature transforms data, for instance, show one ordinary case along with the corresponding result. Then, before any coding begins, ask the assistant to restate the requirement. That explanation becomes an early checkpoint. If its understanding is off, you can correct the mistake while it's still just a sentence, not after it has spread across a collection of files. Now, shrink the job. Instead of asking for an entire application, break the work into small tasks. One task might define a single data shape. Another might implement one function, create one interface element, or write tests for one behavior. The exact order will depend on your app, but the principle doesn't change. Keep each request narrow enough that you can understand its purpose and inspect the result. Smaller tasks don't guarantee correct code. What they do is make the work easier to reason about and validate. Then, when a problem shows up, you've got a smaller area to examine and a much clearer picture of what changed. A useful prompt for that next step can be surprisingly modest. Given this goal and these requirements, help me choose the smallest testable task. Do not implement the rest of the app. Then ask for that task and only that task. Once you've reviewed and validated the result, choose the next one. That changes your role in the process. You're no longer sitting back and waiting for a finished application to appear. You're guiding a sequence of decisions you can actually understand. The app still grows, but now it grows through checkpoints. It doesn't arrive as one enormous block that you're somehow expected to trust all at once. There's another limit worth applying: context. More project information isn't automatically better information. Share only the files that are relevant to the task in front of you. If the assistant is working on one function, include the file that contains that function, along with the definitions or examples it genuinely depends on. Unrelated files can make it harder to tell which details actually matter. Think of context as a filter. You're not trying to hide the project. You're focusing the assistant on the specific part that's being changed. At every step, ask yourself, which files are necessary to understand this task, and which files are simply nearby? Then we reach the midpoint turn. Code is a claim, not proof. An implementation can look completely plausible and still need validation. Compile it. Run the relevant tests. Check every warning and error instead of treating generated code as finished just because it looks polished. If validation fails, take the exact failure and bring it back into the next focused request. Ask what the error means. Ask which assumption might have been wrong and what minimal change would address it. That keeps the debugging conversation connected to observable results, instead of confidence, presentation, or code that merely looks convincing. Dependencies need a checkpoint of their own. When generated code recommends a package, verify that dependency before you install it or rely on it. AI tools can suggest packages that are non-existent or suspicious. Don't assume a package is legitimate because its name sounds familiar or the installation command is delivered confidently. Confirm that the dependency is real and confirm that it's appropriate for the task. If it isn't necessary, ask whether you can complete the same step with the tools already available in the project. Verifying dependencies is part of reviewing the code. It's not some optional cleanup step you save until after the application is supposedly finished. But what if you can't understand everything the assistant has generated yet? Turn the review itself into a lesson. Ask the assistant to explain the code in plain language, one section at a time. Ask what each input represents, what output the code produces, which assumptions it makes, and where it can fail. Then compare that explanation with the implementation that's actually in front of you. You can also ask questions as you go. Why is this condition needed? What changes if this value is missing? Which test demonstrates this behavior? AI assistants can help beginners learn difficult concepts, but an explanation doesn't replace review. It helps make that review possible in the first place. One strong checkpoint is whether you can describe the change yourself. You don't have to recite every symbol in the code, but you should be able to explain what the code is responsible for, how information moves through it, and how you'll know whether it works. If you can't do that yet, pause before adding another layer. Ask for a simpler explanation, a smaller version, or an example that follows one input all the way through the code. The goal isn't simply to receive an answer. It's to finish each step with code you can keep working with, not code that became opaque the moment it was generated. Now, put all the pieces together, and the replacement workflow becomes a verified loop. First, state the overall goal. Second, list the concrete requirements. Third, provide focused examples of inputs, outputs, or implementations. Fourth, share only the relevant project context. Fifth, choose one small task. Sixth, ask for an explanation of the result. Seventh, review the suggested code and every dependency. Eighth, compile it, test it, and check the warnings or errors. Then repeat the same process with the next small task. Notice what changes when you work this way. The assistant can still help you write code, explain concepts, and respond to failures. But now, progress is measured in understandable, testable increments. Every pass through the loop produces evidence you can carry into the next pass. A failed test becomes focused context. A clarified requirement makes the next request better. A reviewed implementation becomes a reliable foundation for the task that follows. The winning workflow isn't to prompt once and trust that the finished app has arrived. Its goal, requirements, examples, relevant context, one small task, explanation, review, and validation, repeated until the app is built. So, in your next AI coding session, resist the urge to open with build the whole app. Start with the goal and then ask, what is the next small testable task? When the assistant gives you an answer, ask it to explain that step before you accept it. Review the code. Validate the result. Only then should you continue. You're not trying to write the longest possible prompt or generate the largest amount of code. You're creating a development process that you can understand, control, and steer. The next small thing is enough, provided you learn from it and verify it before you move on. If this workflow helps you build with AI more deliberately, subscribe to Neural Stack. Like the video and tell us in the comments what small task you're tackling next.